In this video, we start to look at the normal distribution. Here we have an example where something like height, if you look at heights of your friends, is exactly the type of data that would be normally distributed. We'll talk in a bit more detail in the lesson how various factors like gender and various other factors might affect this, but for now we'll just look in general terms, and something like height is typically normally distributed. And in fact, usually we're dealing with continuous data. This is a standardised normal distribution, so it's where we've got a mean of 0 and we're just actually looking at how many standard deviations from the mean the data falls. So here we've got within 1 standard deviation between -1 and 1, within 2 between -2 and 2, and so on. Most of the data lies within 1 standard deviation. You can probably see that visually from the graph. We have about 68% of the data within 1 standard deviation of the mean. And as you can see, it's symmetrical, so we have 34% here and 34% here. Within 2 standard deviations we have 96% of the data. So if we've got 68% here, that leaves another 28%, so 14 here and 14 here. 99.7% of the data is within 3 standard deviations. So we would only have 0.15% above 3 standard deviations from the mean, and the same 0.15% more than 3 standard deviations below the mean. To really simplify, so we can try and understand what this means when we apply it, we'll look at this very simple example of the number of potatoes on a plant being normally distributed with a mean of 9 and a standard deviation of 2. 68% of potato plants produce within 1 standard deviation of the mean number of potatoes. Well, if 1 standard deviation is 2, that means 1 standard deviation below the mean would be 7 potatoes, 2 potatoes below the mean, and 1 standard deviation above 11. So we would have here between 7 and 11 potatoes are produced in 68% of the plants. 96% of the plants, or 2 standard deviations, would be 4, wouldn't it? So we'd have between 5 and 13 potatoes, and then 3 standard deviations, 6, so that would take us between 3 and 15 potatoes. Okay. Another example, here we've got 2 students and results in a maths test. We want to know who does better. Well, there could be all sorts of issues here, couldn't there? Was it the same test? Was one test harder than the other if it wasn't the same test? And if they did take different tests, the fairest way of comparing is to probably compare them against their class. But again, even that, without further information, is a bit hard to judge. We will do that. We'll look at a bit more information. Max gets 64% and the mean in his class is 59%, and the standard deviation is 2%. So that means that 68% of Max's class got within 1 standard deviation of the mean, in other words between 57 and 61 in the test, and so on. Amber gets 75% and her class's mean is 78% with a standard deviation of 3. So if we look here, we can see that here's the mean for Max's test, and with a standard deviation of 2, Max here is quite a bit above it, isn't he? 61, 63, 2.5 standard deviations above the mean, whereas amber, with a standard deviation of 3, is exactly 1 standard deviation below the mean. So, at least based on that, it looks like, although getting the highest score, amber didn't do as well as Max. Max did a lot better. Looking at it in terms of standard deviation is what we call standardising. So we take the score, we subtract the mean, we divide by the standard deviation, and that gives us the standardised score, which is actually how many standard deviations it is, either above the mean or below the mean. This enables us to compare data like this, and we'll be using this a lot. So we'll go through it in a lot more detail in the lessons. Okay, finally, just to put some sort of context on this, although that bell-shaped curve looked very neat, very tidy, and I said at the beginning that so many things are modelled by this, there are also a lot of variations on different types of normal distribution, and we can actually see several here. This here is giving you different means for the different normal distributions, the blue one here, the green one here, etc. And you can see here, this is the variance, so it's giving you the variance, which is the standard deviation squared for each one.